Yep. Okay. So I'll be solving the LeetCode 199 question that is binary tree right side view. So given the root of the binary tree, imagine yourself standing on the right hand side of it. Okay. And written the values of the nodes you can see ordered from top to bottom. So is the sample binary tree 1, then it's 2, 3, then its child node, the left node is null, then it's 5, trees left node is null, and then 4. Person is standing on the right hand side and sees the tree, then it will be 1, 3, and 4. Okay, so definitely you can see a pattern. We can say it's level order. So it's first level, then second level, then third level, and it's last element of each level. So we can do a breadth first search. We can go level by level, breadth by breadth, and after each iteration, maybe after each level, we'll obviously take last element from that level and add it to our um, result list, we can say. So obviously the space complexity will be O of n, or not O of n, but yeah, we can say O of m maybe. So let's say there are n nodes in the list with m depth, or we can say m levels. So the time complexity will be O of n, and the space complexity will be O of m, where m will be the actual depth of the tree, right? So we'll be storing those that many nodes. So yeah, so let's start by first. So we'll be doing BFS, breadth first search. So obviously we'll need a queue. Okay, so let's start by defining a queue. A queue equal to new linked list. Alright, and inside the queue we'll be storing the nodes. So three node. Next we'll also require a uh, result. We can say a list, right? So for that we'll define a list. Yeah, add a list if you want. Add a list equal to alright, and inside the array list will obviously store an teacher. Let's define it as a list, okay? So next, obviously by default, we'll add the root element inside the queue. So for queue, we require forward function to add the element, and we'll add the base element. Right? We'll perform a while loop traverse through the queue. So we'll check the condition if queue is not empty, then only we'll enter the queue. Alright. At the end, obviously, we'll be returning the as array as list. So inside the wait, so and let's go inside the queue. Let's first take the let's traverse to the tree one by one. Let's so initially we have the node one inside the queue. So obviously we'll pop the um yeah we'll pop we can say we'll poll the first element from the queue, right? So but that but the polling will require for all the elements inside the queue, right? So let's say on the first level we have one, so we'll poll one time. But on the second level we have two elements, so we'll obviously poll two times. So for that, obviously we'll require a for loop. It's kind of a nested looping, not exactly, but we can say. And inside it, let's say I zero and I obviously less than. So for the entire queue, so I'll just show you once. Take a sample of this. Let's paste it there. So so let's say we have a queue, alright. Inside the queue, by default, we'll add the element one, and we'll also have arrays list. Right, we'll store the result. Inside, we'll obviously inside the element one. Then we'll poll that one. We'll take in the node. we'll check if that node, okay, um, is the last element of that particular, uh, we can say level. So how we can check that? So we'll check the size of the queue. If the size of the queue is empty, or we can say it's the last element, or once we can say we have traversed all the elements of that level, then the last element obviously will be the rightmost element. Alright. So this is the last element of the queue. That means that is the rightmost element at level 0. So let's say this level 0, this level 1, and this level 2. Alright, so that means we can add it in this. Okay. Then what we'll do, we'll add the left and right child, that is 2, 3. And since it's a queue, we'll pull from the front, right? It's not a stack to pop it from the top side. It's queue. So this will check the element 2. So while checking 2, obviously it's not the last element because once you pop it, there's still some element inside the queue. That means it's not the rightmost element, right? So what we'll do, we'll add the child of the queue. So that will be 5. So now that's an important step, right? Because in this level there are two elements. That means we have to traverse, we have to basically loop 2 times. So as you can see, our queue will be dynamic. That means its length will be changing dynamically whenever we'll be adding the child elements of the given elements, right? So two's child is being added right over here. So that means the queue length, or we can say the queue size, is dynamic. That's the reason we have to initially store the queue's size inside a variable we can say length L, right? By that way, we know that if on the second level we have exactly 2 elements, right? So that means we have to loop it 2 times, and the last element that will be last node that will be taken inside the for loop will be our rightmost element. So this was the first iteration, so we added the child, that is 5. Next, that's the second iteration, that means the 3 node. We'll add first the child of it and we'll add the 3 node inside the res. Alright. Now, now again, we'll check the size of the queue. The size of the queue is 2. That means there are 2 nodes at level 2. Right. We'll check if 5 has any child. So it doesn't have any child. We'll pop it. Is it the last element inside the queue? No, it's not the last element because there is still one iteration remaining. So next we'll consider 4. Are there any child of 4? There's no child, so we'll pop it, right? It's the last iteration, that means 4 is the rightmost element, so we'll add. And guys, that's the result, 1, 3, and 4. So we'll use the same concept inside here as well. So many a times people do the mistakes of adding q dot size over here, and then the queue, basically queue size changes dynamically, right? So it will uh, give a wrong answer. So that's the reason we have to initially define a, let's say, queue length, and we'll store the size of the queue, and we'll take that queue length over here inside our for loop, right? So we'll initially check if the node that we are considering, right? Uh, okay, so we have to pop it first. So we'll do let's say the node. So the we'll pop where the pole basically the element from the queue, right? So we'll have to do it inside the loop. So we'll pull the element, not roll, but pull, right? So then we'll define a certain one variable node. So we'll obviously check if the node is not equal to null, then only we'll proceed further. So obviously we have to add the element inside the queue, right? The left and the right element of that particular node's left and right child. So we can do it by doing something like this, and q dot offer child element, so no dot right. But Here we also have to store the rightmost element and then we have to add it inside our else variable, right? So once our for loop has ended, this whole thing basically tells that the whole we have traversed the whole level. Alright. After that, obviously we can do res dot add. We can add our element, right? But how do we know which element will be having our value? Because this node element will be is defined inside the for loop, right? So obviously we have to define a semi-local element that will store the rightmost element, right? So we can define it as rightmost. Initially, let's define it as null. And if if the node is not null, then we can basically store that element inside the node. Now, why we are doing this? Because the node we want the value of node, and the node we have defined it only inside the for loop, so we can't access it outside. That's the reason we are defining a second element, which will be actually a part of this while loop. That is this rightmost element, and we'll add the rightmost element's value inside here. But then maybe case that the right element can be null, right? So obviously for that we have to check if it's not equal to null, and then we can just add that rightmost element's value inside this variable, right? So let's just go through it and let's check if there are any issues. So taking the null, defining the rightmost variable, that's the whole for loop logic. Finding the node, polling the node from the list. So initially we'll take the first node. That's obviously not equal to null. It goes inside. The rightmost element will take value 1. It will add the two child left and right child as 2 and 3. And obviously the loop ends here. That's the reason it will go inside. It will add the value of rightmost element, that is 1, it is, and it will again go inside because the queue is not empty, it still has the value 2 and 3, and it will repeat the same steps for stop the nodes. So let's run this and check if there are any syntax error. Oh, so it's running properly, the logic is working. Let's submit it and check for other test cases as well. Oh great, so it's working properly. And so if we talk about the time complexity, obviously it will be off and run is the number of nodes as we talked earlier, and the space complexity, that is the size of this array, will be the size, or we can say the depth of the tree, right? So let's say here that 4, that's, yeah, so here there are 4, that's the reason there are 4, right? So this is just, you know, two depth tree, so that's the reason there are 2 elements in the output list. So yeah, that's the sum. Thank you for watching.